Now, in today's class, we'll see the derivation of one-dimensional heat equation. This will also come under a partial differential equation. This is a rod, okay? So I can say, or bar. Based on this, by using this, we are going to prove so how heat will transfer from initial point to end point. Consider a homogeneous bar of constant cross section area A. Let rho be the density, S be the specific heat, K be the thermal conductivity of the material. Let the sides be insulated so that the streamlines of heat flow are parallel and perpendicular to area A. So these are the parallel and as well as perpendicular situations here. Let one end of the bar be taken as the origin O. This is the origin O, and the direction of the heat flows be the positive x-axis. Towards this way the heat will flow from, that's why 0 to towards x, this direction. Let U is equal to U of xt be the temperature of the slab. So this diagram is going to consider a slab at a distance x from, let U is equal to U of xt be the temperature of the slab at a distance x from the origin. Consider an element of bar between the planes. So here planes are P, Q. This is the point Q. Okay, this is the point Q here. Point Q, and this is the point Q dash. So P, Q, R, S. So this what this rectangular is there. P, Q, R, S, one rectangular and one slab I can say, and P dash, Q dash, R dash, and S dash another one. Consider a element of bar between the planes P, Q, R, S and P dash, Q dash, R dash, S dash at a distance x and x plus delta x. So these are the two distance they have maintained. So x, and so this distance is what here, x plus delta x distance from the end O. Let delta U be the change in the temperature in a slab of thickness delta x of the bar. The mass of the element is given by A times, A stands for area, A into rho of delta x. The quantity of the heat stored in this slab element is given by A rho S delta x and delta U. Hence the rate of increase of heat in this slab is given by R is equal to A times rho S delta x into dou U by dou T, and give equation number 1. Now if R1 is the rate of inflow of heat and R0 is the rate of outflow of the heat, we have R1 is equal to minus Ka dou U by dou x of distance x, and R0 is equal to minus times Ka dou U by dou x of distance or length I can say x plus delta x. Give these two R1 and R0 as equation 2, where negative sign is due to empirical law. What is empirical law here? Heat flow from higher temperature to lower. So this negative is option means R0 is what here, higher to lower. So negative sign is going to be mentioned based on this. Negative what sign we have taken? So heat flow from a higher temperature to lower temperature. So therefore we have from 1 and 2. 1 and 2 is given by R. Capital R is nothing but R1 minus R0. So we know the capital R value, R1 value, R0 value. So R value is what here? It is A times rho S delta X into dou U by dou T, and R1 is minus Ka of dou U by dou X of at the distance X, and R0 is nothing but minus Ka of dou U by dou X of distance X plus delta X. This R, R1, R0 will apply in this expression. So this is the value of R, value of R1, value of so R value, R1 value and R0 value. So next, on simplification, so you cross multiply A rho S to the right hand side, okay, and this delta X you divide here, and among this you take Ka as a common. So left inside is dou U by dou X of X plus delta X minus dou U by dou X of X. So this A and A cancels, and take limit on both side as x tends to delta X tends to 0, means take limit on right hand side only. So left hand side will remain as it is. So right hand side, what happens here, if you take limit, so K rho S as it is, so limit of this will become dou by dou X of dou U by dou X according to definition of derivative. So limit of this will become what here, dou by dou X of dou U by dou X, so which is nothing but K of rho S into dou is dou square U, dou X into dou X is dou X square. So this is a result of your right hand side, so which you apply in the equation number 3. So we'll get dou U by dou T as it is, K by delta S as it is, and this is nothing but what here, dou square U upon dou X square, or this may be written as C square, where C square is nothing but what here, K upon delta S, where so this is nothing but deficity of the substance is going to consider, where I am considering as C square. So this is nothing but a heat equation which can be written as notationally Ut is equal to C square of Uxx. So this is the one dimensional heat equation.